Hi guys. So in this video, we're going to answer this question that I've came up with just now. So it's a potential question you could get, and it's again about what I've been talking about in a couple of my recent videos about calculating the magnitude of a force exerted on a pulley. So let's say we've got this pulley system like this. We've got a pulley system with this A block connected by a light string. I didn't write this here, but let's just assume the string is light. So light string. And it's connected to block B over a smooth pulley, so there's no friction in the pulley, but it lies on a rough plane. So this A lies on a rough plane, so there's friction in the plane. Let's say the mass of A is 10 kilograms. Let's say the mass of B is 50 kilograms. So we know from the question, so if we've got a mass of 50 kilograms, we know that the motion of the connected particles is going to move down like this because this is a bigger mass than that. So it's going to go down like that. Is going to want to fall downwards down here. The coefficient of friction is, let's say, a quarter. We've got a smooth pulley. So again, as I said, no friction in the pulley. And tan theta is 3/4. So the question is, again, calculate the magnitude of the force exerted on the pulley. So the force which is exerted on the pulley by the string. So by the tension in the string in this part and the tension in the string in this part. So that's what we want to do. So we want to calculate the magnitude of this force pushing down from the string, so from the string component there, the string component there, down into the pulley. That's what we want to calculate in this video. Okay, so just a point then. So I know that in a couple of videos before, I gave you this formula. So I showed you this formula here, and we proved that formula. So the whole point of those videos was to show you that you can arrive at a formula for getting this magnitude. So I wouldn't recommend actually just copying that formula in the exam and then working out your t value and then working out your theta value and saying, okay, well, let's just substitute that into the formula and that's our answer, because you probably would lose method marks because you've got to kind of explain how you arrive at this formula here. So what we're going to do in this question, I'm going to go through how I would actually answer this question if I was doing this question in an exam. So I'm going to check my answer at the end using this formula, but I'm going to show you how I would answer this question if this question was in my exam. Okay, so we can, as I said, we can use this formula which we showed to check the final answer. So that was the whole point of the videos before. We can use the formula to check whether our answer is correct, but just stating the formula and plugging in the tension and the theta, I don't think that's going to be enough to get you the marks. So I don't want to give you, information which is going to cost you marks. The formula is correct, it works, but you don't want to be losing method marks, and I don't want you, to be just copying down random formulas without showing where that comes from. So you don't have to prove this formula. You don't have to prove this formula in the question. You'll see when I do this question how I do it, but you can use the formula to check, did you get the right answer? So that was the point of the question. So as I say down here, substituting t and theta into this formula is not enough for full marks, but we can use it to check our final answer. Right, so how are we going to work this out? So we want to find, as I just said now, we're trying to calculate the magnitude of the force exerted onto the pulley by the string. We want to calculate the magnitude of the force pushing the pulley down from the string. And I've not actually joined my string up here. Let me just join the string up to that. Okay, right. So let's draw a little force diagram. So I've kind of drawn some forces here. So we've got this A block, which has got a mass of 10 kilograms. So your force is 10 G. You've got this block B here. So this, again, this is your B there. That's your A there. And you've got this 50 G weight going down there. Now we've also got friction. We've got a rough plane. So remember, in the question, we got friction in the question with a coefficient of friction of 1/4. So I'm actually just going to write this down here then. So we know that friction, so our formula for friction is that friction equals mu times r. The reason why it's equal to mu times r, not less than or equal to mu times r, is because we're going to assume that the connected particles are moving. So when your connected particles are moving, so when this A block is moving upwards and when the B block is going downwards, if there's acceleration, and in this question, we'll assume there's acceleration because the way that I've designed this question is that my coefficient of friction is quite small, so it's only 1/4, and my 50G is much bigger than my 10G. So there is going to be it's going to accelerate to the right. Basically, it's going to accelerate down. The connected particles are going to accelerate downwards. So friction is equal to mu times r. So my mu is 1/4, and my reaction force, my R, is my normal reaction force on the from the plane onto the block. So my normal reaction force there, my perpendicular reaction force there. So what is that normal reaction force going to be? So it's equal and opposite to the component of weight perpendicular to the surface. So this component of weight there. So remember, this is theta. Again, that's the same theta as that. So this reaction force, we can say that this reaction force is equal to 10g, so 10g cos theta. So 10g cos theta is our reaction force. So let's just write this down here, because again, equal and opposite forces. This reaction force, this normal reaction force, is the same as this component of weight perpendicular to the slope. So our friction is going to be 1/4 times by 10g cos theta. We've also got another component of weight parallel to the slope. So this component of weight parallel to the slope, and that's opposite the theta. So this is going to be 10g sine theta this time. Okay, so we know that tan theta from the question is 3/4, because the question says here that tan theta equals 3/4. So how can we use that to get sine and cos? Well, we can draw like a little triangle here. So remember, tan is opposite over adjacent. So it's opposite over adjacent. It's got a theta there. Opposite side of 3, adjacent side of 4. What would our hypotenuse be? So you can use Pythagoras to do this, but it's going to be 5 when you work that out. So we know, therefore, that sine theta is opposite over hypotenuse, so 3/4. Sorry, 3/5, sorry, my bad. And we know that cos theta is equal to adjacent over hypotenuse, 4/5. So we know that our friction is going to be a quarter of 10. Well, that's going to be 2.5. So that's going to be 5/2. So 5/2g, and then times by cos theta, which is 4/5. So you're going to get, so 2.5 times 4/5, that'll actually give you 2. The 5 there cancel out. 4 divided by 2 is 2. So you get 2g. So the friction force is 2g newtons. Okay. Now we've also got, again, this so friction is opposing the motion, so you got 50g newtons pulling you downwards, but you've got friction which is opposing the connected particles in the other direction. And remember, you've also got this component of weight. This component of weight parallel to your slope is also counteracting the willingness of the connected particles to go downwards, because obviously this 50g newtons is accelerating the whole thing down, but you've got opposite reaction forces which are trying to pull you backwards. You've got the friction, and you've got this component of weight as well. So don't forget that component of weight. So we've got this 10g sine theta. Now we know that sine theta is 3/4, as we saw over there. So this is going to be 10g times by 3/5. Sorry, my bad. 3/5 is sine. So 3/5 of 10. That's going to give you 6, so 6g. So what we've got when we do F equals ma, so let's look at F equals ma for the whole system. So we're going to do F equals ma for the entire system of connected particles. So what is our driving force driving the entire connected particles downwards? Well, that's the 50g. So that's our driving force. What are our resisting forces? So what are the resisting forces opposing the connected particles? So remember, that's our friction, and that's our component of weight going down there. So we're going to do 50. So our resultant force of the connected particles, so it's 50g, and then take away our friction. So take away the friction, and then take away this 10g sine theta, which we just worked out to be 6g. So let's just simplify all of this. I'm just going to move this up. So what we get is we get 50g, take away friction, which is 2g, and then take away this 10g sine theta, which was 6g. So our resultant force, so our driving force, take away our resisting forces, is going to be 50 take away 2 take away 6, which is going to be 42g. So 42g, and that's equal to the mass of the entire system times by acceleration. So what's the mass of the entire system? The mass of A is 10, the mass of B is 50, so the mass of the whole system is 60. So the mass is 60. So remember, resultant force is equal to the mass of the entire system. So F equals ma for whole system. It's the resultant force is equal to mass of both blocks added up times acceleration, so 60 times by acceleration. So we know that the system is accelerating with an acceleration of 42g over 60 in this kind of like downwards direction there. So that's our acceleration. So 42 over 60g. If I just get my calculator, just to simplify that. So yeah, 42 over 60 times by 9.8. So we've got an acceleration of 6.86 meters per second squared. So 6.86 meters per second squared. That's our acceleration. Okay, so why is calculating the acceleration helpful? Because now we can work out the tension. So the good thing about knowing this formula to find the magnitude of the this m that we want to calculate is that we know what we need to work out. So we know that to get this magnitude, we need to work out the tension, because otherwise we can't do the question. So we need to work out that tension. So how can we now work out the tension? Let's go to a new slide to do this. So again, I'm going to draw up my diagram again. I've got my block there. I've got my pulley up there, connected down there, connected to this block down here. And I know that I've got my 50G down there. I've got my, again, my 10G down there. But I've got the component of weight going down this direction. So this component parallel to the slope, which we calculated to be 6G. So we've got this 6G opposing the motion. And we've also got this friction, which we calculated to be, that was 2G, wasn't it? Yeah, 2G. So we've got friction of 2G there. So what we can do now, so I mean, if we think about, if we imagine that we are this A block, then we feel tension pulling us forwards. But if we're this B block, we feel tension going against our motion. So tension is trying to push us back, pull us backwards. So what we need to do now is we need to do F equals ma. So we're going to apply our F equals ma formula, but for one of these blocks. So generally speaking, the easier block to do F equals ma for is your one which is in free fall. So your one which is like hanging in the air. So I'm going to do F equals ma for B. And this is going to help me calculate the tension. So imagine that we are B. So imagine you are literally this B block. What do you feel driving you forwards? You feel the 50G newtons driving you forwards. And what do you feel trying to pull you back? You feel the tension, it's takeaway tension. And that's going to be equal to the mass. So remember, this is the mass of B. We're just focusing on B. So the mass of B, which is 50, and then times by the acceleration. Well, the acceleration for this connected particle, for these connected particles, is the same across the board. It's the same as what we just calculated there. So that's why we calculated that acceleration, because now we can just plug that into here. So 6.86. And now that's going to allow us to work out the tension in the string. So let's just move this up. So therefore, so 50G is equal to 50 times by 6.86 plus t, so just add t to both sides. So that means that 50G take away 50 times by 6.86 is equal to tension. So we can do that on the calculator. So 50 times by 9.8 is going to be 490. So we get 490 take away, so 50 times by 6.86, 343. So that's going to give us a 490 take away 343. So we get a tension of 147 newtons. So a lot of tension in the in the string. Okay, so that's our tension. So we know our tension force. So you could, if you wanted to, I mean, now we know the tension. If you go back to the formula, we know tension is 147. We know sine theta, that was 3/4, as we showed over here. So tension is 3/4. So if you really wanted to, you could plug that into the formula and you could work out your answer, and that would be the final answer. But in an exam question, again, I wouldn't quite do that because you're not showing how you've got this formula. You can't really just plug out random formulas that you're not taught in the syllabus from thin air. But again, I wanted to give you that formula so that you can check the answer. You can check that whether you get, the correct answer. So let's go ahead now and work out the magnitude of our force acting on our pulley. So we've got our pulley there. We've got tension in the string there, and we've got tension going down here. So we just worked out the tension. So imagine that you are this pulley. What do you feel? You feel tension trying to pull us down this way, the tension in the string trying to pull downwards, and you also feel the tension trying to pull you downwards vertically down here. So tension, remember, was 147, and tension there was also 147. So that's what we feel. So now then, what we can do is we can say, okay, how are we going to work out the magnitude? So this magnitude of force, which is pushing into the pulley, how are we going to work out that magnitude? So we can use the method that I demonstrated in my proof when I tried to prove the formula. So what we've got is you've got our tension of 147 newtons. We're splitting, remember, we've got, let me try and draw the diagram again of the ramp. So you've got your pulley up there. You've got an angle there of theta. So this angle there is going to be 90 minus theta. Remember, you've got a right angle there. So this angle there is a half of that. So this is 90 minus theta over 2. And that angle there is also a half of that. So 90 minus theta over 2. So then what you can do, so as I've done over here, I'm actually just going to use the color blue instead, just to make it look as neat as possible. So we've got the tension of 147 newtons going down there. You've got this vertical tension, 147 newtons going down there. And then you're going to split. So we want to find this magnitude. You're going to split that into half. You're going to split your angle there into half. So let me go to a new page. So what I'm going to do on the next page is copy this diagram. Okay, I'm just going to copy that diagram that we got there. So we've got 147 newtons going down like that. We've got another 147 newtons going down like that. And we're going to split the angle into a half down like that. So we've got, again, 90 minus theta over 2 there. And in here, 90 minus theta over 2 there. So the technique in my proof that I showed you in the video where we can get the formula for this magnitude. So remember this dashed line here is our magnitude. This is what we want to calculate, this magnitude force. So the way that I did this, as I said, okay, let's move this force down to here. I've not done this very accurately, but essentially this dotted line should connect down here. So it should connect down there. Let's just pretend it does. That's how it should happen, because what you get basically is a parallelogram like this. So that's why, you know, this 147 that I moved down here will connect perfectly when you split it in half like this, because you basically get a rhombus. So we've got this there. And then the way that I did this proof was I just copied out this triangle again. So 147 newtons, down there 147. You've got, if we just connect this up like that, so you got your 147 newtons going down there, 147 newtons going down there. The magnitude over here, which you want to calculate, this angle there, again, if we just write that there, 90 minus theta over 2. This is an isosceles triangle, 147, 147. So again, this is going to be 90 minus theta over 2. Now, what I showed you in my proof is that this angle there is 90 plus theta. So that's what I showed you in my proof, that this angle there is 90 plus theta. So what we did in the proof when I proved the formula is I said that was 90 plus theta. So then what we can do is use that cosine rule formula, where we can, again, if I just redraw the triangle again, and I'll do it in red. So redrawing that triangle, 147, 147, magnitude going down there, which is what we want to calculate. We've got our 90 plus theta there. I used the cosine rule formula, and I found out that when we use the cosine rule formula, we get m squared is equal to 147 squared plus 147 squared, take away 2 times 147 times by 147, which is 147 squared, and then times by cos of 90 plus theta. And then what I showed you in that proof video is that cos of 90 plus theta is the same as minus sine theta. So with this example here, you can just write, yes, we get 100, so 2 lots of 147 squared here, and then take away 2 times 147 squared, and then times by minus sine theta. So you don't have to explain how you go from cos 90 plus theta to minus sine theta. I mean, it's not, you don't need to waste your time doing that, but you can just go straight from there to there, because it's not, I was going to say it's an obvious fact, but I mean, it's one of those facts that, you know, you don't need to explain. I mean, you can explain it using a graph, so you don't have to explain this in words. You don't have to do any maths to explain that. Right, so then what you can do now is we know sine theta because we know sine theta in the question was equal to 3/5. So then what you can do is just plug this all in. So you're going to get m is the square root of all of this. So 2 times 147 squared, take away 2 times 147 squared. Well, actually, we got a minus and a minus there. So minus times a minus number gives you a positive number. So that's where you get that from. And then times by sine theta, which is 3/4. Sorry, 3/5, sorry again. So you can plug that all into your calculator, and then you get your magnitude. So you get your magnitude of the force, exerted onto the pulley. So that's how you do that. You plug all those numbers in. Let's see what we get. So 2 times 147 squared, and then plus 2 times 147. Sorry, I forgot the squared there. My bad. There should be a squared here. Squared. 2 times 147 squared times by 0.6. I square root all that. So the magnitude of the force exerted onto the pulley is 262.96 newtons to 2 decimal places. And again, if we really want to, we can check that answer with our formula that we proved. So the magnitude is equal to the tension times by the square root of 2 times 1 plus sine theta. So remember, our tension in the string was 147. You times that by the square root of 2 times 1 plus sine theta 3/5. So we're going to get 147 times by 2 times by so 1 plus 3/5, that's going to be 1.6. So times by 1.6. Plug that into your calculator. Let's see what we get. 2 times 1.6 square root that answer. So square root answer times by 147. We get the same thing we got before, 262.96 newtons to 2 decimal places. Now, that's how you can write your answer there. So you can do this kind of argument there, and that would get you full marks by doing this argument that I've done there. Now, there is another method as well, and someone did point this out to me in the comment section, and actually you guys might find this easier, this second method. So I'm just going to go through this second method. So again, this is method number 2. And this before was method number 1. So this was the method we did here. Let me just, again, make my writing smaller. So you can use this first method here. So method 1, or you can use this second method, which I think is actually probably quicker. So you can use this if you want to as well, if you understand it better using this method. So you got your pulley there, you got your string with your tension there, which is 147 newtons, and then you've got your string again with tension of 147 newtons there, and we want to calculate the magnitude. So another way that you can think about this is you can think about it like this. So this magnitude going down into the pulley, this magnitude m, and I'll call this m. So this m is equal to the component of this 147 going downwards like this. I mean, if I draw like two, let me draw like two right angle triangles. So you got your 147 going down there. You've got your other 147 going down there. What you may prefer to do is draw like two right angle triangles, like a right angle triangle like that. And then another one like this, where sorry, this is a really bad diagram. Let me do this again. I'm gonna move this all to the side here because I want to be as neat as possible. So you've got your 147 there, and then what you can do is you can make a right angle triangle where this 147 is your hypotenuse, and again you can do the same thing with this other 147 going down there. So your 147 going down there, and then you make like a right angle triangle with that as your right angle there. So what you may prefer to do is you may prefer to say, okay, so we know that this angle there is 90 minus theta over 2. And again, this angle there is 90 minus theta over 2. And then what you can say is, okay, well, if we add, so with this right angle triangle here, sorry, let me I'm going to rub this all out again and redo this because I'm not, my triangles there are not accurate. Let me try and do this again. Right. So imagine you've got the right angle triangle there for this 147 going diagonally down like that. And now let's make another right angle triangle with this 147 as my hypotenuse and a right angle like that. So what you could do, so I've got two right angle triangles, so 147 newtons there, going down like that. And I've got a component going down in the same direction as my magnitude, so this component there. So I call this component 1. So this is triangle number 1. This is triangle number 1, right angle triangle number 1 with 147 as my hypotenuse. I'm going to draw again another right angle triangle like this with my 147 going down there, my right angle there. And I've got this other component as well, this component 2, which on this second right angle triangle, so right angle triangle number 2, is also going down in the same direction as this magnitude. So going down in the same direction as the M. So what some students prefer to do, and again, this is probably easier, is that you can actually do C1 plus C2. So your magnitude is C1 plus C2. So if you can work out component 1 and component 2, add those together, that would be the magnitude. So if we call this in here, this angle 90 minus theta over 2 again, because remember, we're splitting that angle into half, and this angle there, 90 minus theta over 2, what we can actually do is take components, take the adjacent component of this 147 newtons for both of these right angle triangles, add them together, and that's our magnitude. So let's start with triangle number 1. So 147 going down there. This is triangle number 1. Right angle triangle like this, and this angle there, 90 minus theta over 2. So this C1, so right angle triangle, you got adjacent, you got hypotenuse. So C1 is going to be equal to hypotenuse, so 147 times by cos 90 minus theta over 2. So what you could do is you could work out, so we know from the question, that sine theta is equal to 3 over 5. So what you could do is you could say, okay, well, theta is equal to inverse sine of 3 over 5. And then you could plug that into the theta there. And then you could obviously get the theta, plug that into your formula. So 90 take away the angle divided by 2, times that by 147. And then you get this C1 component. And then you can do the same with the C2 component. So again, you've got your C2 component going down there, your 147 newtons going down vertically. Again, you've got a right angle triangle like this. So right angle there, that's supposed to be a right angle. This 147 must be the hypotenuse. Again, you've got your 90 minus theta over 2 there. So you could say, okay, so again, adjacent, your C2 is adjacent to the angle. Hypotenuse is 147. So that's going to be 147 times by cos of 90 minus theta over 2 again. So what you would get when you add C1 and C2 is you would get double this 147 cos of 90 minus theta over 2. So what you'll get is that your magnitude of your the magnitude of the force exerted onto the pulley is equal to 2 times by 147. So 147 cos of 90 minus theta over 2. So this result here will give you the same result as we got before. So if we just plug in, so we know that theta is equal to sin inverse of 3 over 5. So we can plug that into our formula. So 2 times 147 cos 90 minus sin inverse 3 over 5. Obviously, just make sure your calculator's in degree mode with this. So we're going to plug this all into the calculator. So first of all, sin inverse of, let me just check my calculator in degrees. It's not, let me change it to degrees. Sin inverse 3 over 5. You get about 36.87. 90 take away that answer, divided by 2, and then take cos of that answer, times by 147, times by 2, you get the same result. So we get 262.96 newtons. So again, if you prefer to do it like that, that's fine as well. And in fact, as I said, if you can, that's probably an easier way to think about it, just by adding the component 1 of this 147 newtons and component 2 of this 147 newtons, and they're exactly the same thing because the tensions are both the same thing anyway. So when I go back to my diagram here, really, like this length here should be like the same size. So I mean, ignore this like blue line here, because really they should be the same triangle, but obviously it's quite hard to draw that on a diagram. That's why I kind of extended the length downwards like that. But they should be both right angle triangle. Sorry, not that, that's wrong. Sorry, this should be a right angle there, and that should be a right angle there, because that's your height. That 147 is a force. It must be your hypotenuse if you're going to take components of it, and that 147 there is also your hypotenuse. So yeah, that's what you would get. So you can also say, so we'll go to a new page for this. So you've got two formulas that you could use. So the magnitude of the force exerted onto the pulley is equal to, so you could use this formula. So tension times by the square root of 2 times 1 plus sine theta. And that's also equal to 2 lots of, so 2 lots of the tension. So 147 was our tension. So let's just make a note of this. That was our tension there. So 2 lots of the tension times by cos of 90 minus theta over 2. So you could use either one of those formulas to check the answer. But if you were doing an exam question, right, make sure you do either method number 2 or method number 1, where you go through the process, where you guide the examiner through the process of how you're guessing the answer. So it's probably, as I said, probably easier just to use this method 2, where you take components. But I personally find it easier. I mean, it's just a personal thing. I find method 1 easier to understand where the magnitudes come from. So I kind of, my mind, I understand, I see where this magnitude of force is coming from by kind of creating this like triangle here, and then saying, okay, well, if we're adding these two vectors together, then that's our magnitude of force there. That's kind of how my mind works. But if you prefer to think about it using this easier method where you just add this component and this component together, and then you get your magnitude, of course, that's fine as well. So again, so if you're doing this in the exam, do either method number 1, so draw your triangles, to take your components, so component number 1 equals component number 2, add them together, and then you get your magnitude. Or you can do this kind of cosine rule method, that again kind of makes more sense in my mind, but it's a harder method, but it makes more sense to me, where you construct this triangle, you do your cosine rule, and you get your magnitude there. And then if you're not sure about your answer at the end, use either one of these formulas to check your final answer. Any questions, again, please do leave it in the comments below. So hopefully that was useful.